Okay, welcome to video number 2. Today we are going to be covering topics such as word problems, systems of equations, solving them graphically, using substitution method and elimination method. And then we're going to modify the second example of that to turn it into a system of linear inequalities, and we'll see how that goes graphically. So I'm not going to do every single one of these word problems. Obviously, we will be posting the answer key to this review packet on WITS, so if you want to try some of the other ones that I'm skipping, feel free to. But the first one I'm going to attempt with you guys is number 18. This is what we call a larger, smaller type of word problem. So this one, it says the larger of two numbers is 5 more than the smaller. So the first thing we need to have is a let statement. Let's let x represent the smaller number. And if the larger number is 5 more than that, hopefully when you hear 5 more than, you think addition. So x plus 5 would equal the larger number. Okay, let's keep reading now that we have our let statement. When twice the larger, so when twice the larger number, so 2 times the larger number, is increased by the smaller number. So 2 times the larger number increased, I think add the smaller number onto that, so plus x. The result is, there's your equal sign, and then 55. So you get usually typically about a point, if you have a let statement, a point for the correct setup of your equation. And now let's solve. So distribute. Since in our first video we did solving equations, this part should be pretty easy. You guys were fantastic with it. Coming from 8th grade, so I don't expect it to be too bad now. Oh, and I made a mistake. That should be a 3. So should this. Sorry about that. 45 divide by 3, divide by 3. And so x equals 15. The only way that I could see any of you kind of making a mistake on this is to not answer the whole question. The whole question says to find both numbers. So if x is 15, okay, if the smaller number is 15, then 5 more than that would be the larger number, which would be 20. So you can either write smaller number equals 15, a larger number equals 20, or you could go back to your let statements like I did and write the answers next to that. Okay, I am going to do number 19 as well. Perimeter. So perimeter, remember, is like a fence or the outside distance around the outside edge of a shape. And in this case, it's triangle. It says the perimeter of a triangle is 32 meters. The second side is 2 more than the first side, and the third side is 2 less than twice the first side. So both the second and the third sides of our triangle all relate back to the first. So the second side is 2 more than the first side. So 2 more than the first side. So let's make x be our first side. So if it's 2 more than that, it would be x plus 2. And then the third side is 2 less than twice the first side. So 2 less than twice the first side would be 2x minus 2. The perimeter, so all 3 of these expressions, the first side plus the second side plus the third side equals a total of 32. So let's combine our terms. X plus 2x is 4x's. This 2 and this 2 actually are additive inverses, so they cancel each other out. Divide by 4, and I get x is equal to 8. And yet again, please make sure you answer the whole question. It says find the length of each of our sides. So let me change my color real quick. Let me turn it to red. So if x is 8, that means the first side is 8. The second side would be 10, and then the third side would be 2 times 8, which is 16, minus 2, which is 14. So those would be our 3 different lengths. You could also write them this way, in curly brackets, 8, 10, and 14. All right, I'm going to skip all the way down to number 23. Like I said, the other ones are You can try them. The answer key will be on wits if you'd like to. But I want to try consecutive, 3 consecutive odd. So before I go any farther, 3 consecutive odd, let's do our let statements. You always let x represent the first integer. But to get to the next odd, so think like, how do I get from 3 to 5 and 5 to 7? You have to add 2. So it's the same thing. Even though we're looking for odd integers, I'm still adding 2. So second odd, and then I add 4 to get to my third odd integer. Okay. I apologize for how bad my handwriting is. Such that the sum, so sum means to add the first and the second. The sum of the first integer, which is x, plus the second integer, which is x plus 2, is, there's your equal sign, equals 27 less than 3 times the third. 27 less than 3 times the third, which means I have to do 3 times the third and then take 27 away from it. All right, I'm going to distribute and combine like terms in the same line. So that's going to be 2x plus 2. This will be 3x plus 12 minus 27. And I can keep solving from there. Oh, I keep messing up, man. I'm so sorry. All right, minus the 2x to the other side. 2 is equal to x minus 15. Add the 15. All right, x is equal to 17, and then it wants the 3 consecutive odd integers. So if 17 is my first odd integer, then it would be 19 and then 21. Okay, 25 is my next question. It says, if you buy 2 pounds of Tootsie Rolls at $1.80, how many pounds of caramels at $2 can you buy if you want to pay $1.95 for the mixture? So I'm going to set up a chart here. I'm going to let TR stand for Tootsie Rolls. I'm going to write caramel or carm for caramels, and then my mixture. This is kind of like when you go to the bulk food section and you scoop them all into the same bag. So those are my 3 categories going sideways. Across the top, I hear 2 different things. I hear pounds versus cost. So one category I put amount, and the other category I'm going to put how much it costs me. So let's see. Tootsie Rolls, I am buying 2 pounds, so that's the amount I'm purchasing, and it costs me $1.80. How many pounds of caramel? So I do not know how many I'm purchasing, but I know it's going to cost me $2. If I want to buy a mixture, that is $1.95 per pound. So if I'm taking 2 pounds of Tootsie Rolls, and then I am buying X pounds of caramels, and I'm putting them together in the same bag, I'm adding them together in the same bag. So I would have caramels plus Tootsie Rolls together. So now this third column in my chart is when I multiply straight across. So 2 times $1.80 is $3.60. $2 times X would be $2 for every pound of caramel. And $1.95 for the mixture, which is the caramels plus the Tootsie Rolls put together. So now I set up my equation. Tootsie Rolls plus caramels equals the mixture. Distribute. So $3.60 plus $2 for every caramel is equal to $1.95. $1.95 X plus $3.90. All right, start solving for X. So I'm going to move the $1.95 over to join the $2. Just beware of your decimal places here. I strongly encourage you to use a calculator if you don't trust your decimal placement, because $2 minus $1.95 is 0.05, not 0.5, and this is going to be equal to 0.30. So when I divide 0.05 to the other side, I get x equals 6. So it asked if you bought how many pounds of caramels. That was the question that we had to answer, and it would be 6 pounds. 6 pounds of caramels. Skip down to number 28. A mother is 40 years old and her son is 8. In how many years will the mother be 3 times as old as her son will be? So a mother right now, so mom, son. Now, future. Okay, a mother right now is 40 and her son is 8. It's asking in how many years? I don't know. That's what I need to find out. So in math, when we don't know something, we usually let that represent by x. So in the future, x years. I don't know how many years, so 40 plus those years and 8 plus those years. It said the mother will be 3 times her son's age. So the mom will equal 3 times her son's age. So the mom is 40 plus x. The son is x plus, or 8 plus x, or however you want to write it. So I need to know when those two things are equal to each other. So if I distribute, equals 24 plus 3x, and I get my x's all on one side and 24 to the other side, I get 16 is equal to 2x divided by 2. And so that means in 8 years, the mother will be 3 times her son's age. All right, last of these word problems that I plan on doing is number 30. It says consecutive odd again, and I need 3 of them. So we just did those let statements. So I'll just quickly jot those down. Such that the sum of the first and the second, so if I add the first and the second together, the sum of the first and the second is more than. That's when you know it's an inequality. If you see the word is more than, not just is 27, it's is more than 27. So it's greater than 27 less than 3 times the third. So we just did this exact same question when it was an equal sign, and now all of a sudden it's an inequality. So I'm going to pretend that we did all the solving just like we did last time, and we ended up in this final answer. So instead of an equal sign on number 23, it's now an inequality sign for this question. So if you read this question, this says x is greater than, or well, actually, it ends up being this way. Let me erase that because we end up dividing by a negative. So let me erase that. We end up dividing by a negative, so it flips our inequality. So this is going to say less than. X ends up being less than 17 because in the solving of this, if you go back to number 23, we ended up dividing by a negative. So if x has to be less than 17 and it has to be odd, you need to think of the next odd number that is smaller than 17. So that would actually mean 15 is our smallest odd integer. Then the middle one would be 17, and then the one greater than that would be 19. So if you do the math out, you'll see what I'm talking about. All right, I have 2 more questions. I'm going to try and keep this one around 20 minutes. So 2 more questions. This next one we are going to be solving graphically and using elimination and using substitution, and we should get the same answer for all 3. So if I want to graphically solve these equations, I need to get them in y equals mx plus b form. So that's my plan. Which means the top equation, I'll stick with my red or my blue pen for this one, I'll do red for the second one. This is not in y equals mx plus b form. So to do that, I would have to subtract x to the other side. So I have negative y is equal to negative x minus 2. Divide by the coefficient in front of the y. So I'm going to graph this equation in blue. So I have a y-intercept of 2 and a slope of up 1 over 1. Remember, when you're doing systems of equations, you have to label at least one line, if not both. So there's the first graph. I'm going to do the other one in red. This one also is not in proper form for me to be able to graph it. So again, I'm going to subtract x to the other side. So I have negative 2y is equal to negative x plus 4. Divide by negative 2, divide by negative 2, divide by negative 2. So I get positive 1/2 x minus 2. That one I'm going to graph in red. So this time my y-intercept is negative 2. And my slope is up 1 over 2, up 1 over 2, up 1 over 2. And if you do all this beautiful, brilliant work and then you don't tell me what the answer is, I can't give you full credit, which makes me really sad. Oh my goodness. It is hard to do this with my, with my little pen here. There we go. Let me connect those lines and I'll draw on my other one. Okay, so if I was better at using my little stylus here, my solution point appears like they would have crossed negative 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2, 3, 4, 5, 6, if I could actually draw a straight line. But of course I went a little crooked with my blue line. Okay, so they cross right here at negative 8, negative 6. If we're going to solve the same equation using the elimination method and the substitution method, I should get the same answer every single time. So now let's do elimination method. These are perfectly set up to do elimination. The only problem with it is I don't have opposites. So to force there to be opposites in these, I need to multiply through by something that is going to force that to be. So I'm going to multiply the bottom equation by a negative 1. And so when I multiply through by a negative 1, I end up getting x minus y is equal to negative 2, and the bottom becomes negative x plus 2y is equal to negative 4. All right, so I'm going to draw my line, and my x's are going to cancel each other out. And so negative y plus 2y is 1y, and negative 2 minus 4 is a negative 6. Well, luckily, that's exactly what we got as our x value when we graphed it. And to get the y value, and now to get the x value, I'm going to plug that in. So I'll plug into the bottom equation. So x minus 2 times negative 6 is equal to 4. So I just chose the original bottom equation from the very top of the page. And there we go. We got negative 8, negative 6. So my answer matched what I got graphically. Substitution is when you literally replace one with the other. If I utilize the fact that I know that the top equation is equal to y is equal to x plus 2, and the bottom equation is this equation, all I'm going to do is take this part of it and replace the y in the second part of it. So I would have x minus 2 times, and then I replace the y with x plus 2. Distribute x minus 2, x minus 4 is equal to 4. X minus 2x is negative 1x, and if I add this 4 to the other side, I get 8, and there we go. We get negative 8 as my x value, and I hope you can assume that we would get negative 6 when we plug it back in, because that's what we've gotten over and over and over again. The only thing that I want to do briefly in the last few minutes here that I have with you is systems of linear inequalities. So we can't do elimination and substitution method when we do inequalities. So if you guys want to change this to be an inequality. Let's make it a less than or equal to symbol. And then let's make this one also a less than symbol. Okay, so if I want to graph these, I do need to get them in what, for lack of a better term, y equals mx plus b form. Let's just get it in slope-intercept form. That looks backwards to me, so I'm going to rewrite that. Notice the alligator's eating the y, so if it continues to eat the y, here's one equation, here's our other equation. So just a couple things before we call today a wrap. Let me do this one in red. All right, it has a y-intercept of 4 and a slope of up 2/1. Now, because this is an inequality, I have to worry about whether or not I'm going to be connecting these with a solid or a dashed line. Well, luckily, because our inequality that I wrote in is underlined, meaning equal to, I can actually connect these with a solid line. I'm going to label it. And because that's a less than symbol, I'm going to shade below. All right, let me switch to my other color. Let's do blue. I'll do this one in blue. This one has a y-intercept of 5, so 1, 2, 3, 4, 5. This one has a slope of up 1/1. Okay, up 1/1. And this one actually is greater than, but not equal to. So this one's going to be a dashed line when you connect it. And because it's a greater than symbol, we're going to shade above, which might not be the most amazing example, but that means that our solution point is up here in this double shaded region. So this little sliver up at the top. Remember, we don't pick the point where they cross when we use systems of inequalities. We always pick the point in the double shaded region. So in this case, it would be that tiny, tiny little sliver up at the top of the page. All right, that's the end of today's video, and I will see you all next time. Work on that homework.